We're good to go. All right. Hello and welcome, everybody. My name is Nate Prorock, Director of the UCSF Launchpad. We're really excited to host the third iHackHealth Appathon, starting off with this kickoff event today. There's a lot of information that we want to cover, but the first thing that I want to do before we get started is to say a big thank you to the whole team that's put this together. There have been many people behind the scenes these past few months, so thank you to everyone who's helped. From everyone at UC Berkeley and Apple and UCSF, again, sincere thanks. This event really couldn't have been done without you. So what is the iHackHealth Appathon, and what and why and how are we doing this for the third time? This is a project that is very important to me. Oftentimes, I get told by UCSF investigators that they have a great idea for an app to develop that could tremendously help patients, advance research, make life easier, and even save lives. But they don't know how to create the app. And I'm not a programmer, so I didn't really know where to start. That is, until connecting with the Fung Institute at UC Berkeley. And those from UC Berkeley looking to work on these projects, you'll actually be helping make change in the clinical and research settings with these apps. I can definitively say from our experience hosting the first two Appathons that this event can have profound impact on the projects and how the projects make a difference in the world. As mentioned, we have a lot to cover today, and here's the general schedule. We'll start off with some logistics on the Appathon and what the next 2 weeks might look like. Then we'll play the UCSF PI's elevator pitches of the problems that they're working to solve with apps. Then we'll have Tamira James from Apple give a great presentation on some of the different development frameworks that might be utilized to help solve these problems. And then what's really exciting in the second hour, we'll ask you to join breakout rooms with your UCSF-based PI on the proposals that you've signed up for. Also, keep an eye in the chat because we may post different documents to reference, including the Google Sheets or the Google Docs sign-up spreadsheet. Again, you may have seen this, but I just want to reiterate it again. Please keep in mind that you can only sign up for one Appathon project. We've learned that it's just too much for anybody to try and work on more than one project at any time on this. And if you have any questions during this presentation, please write them in chat, and one of the hosts will be happy to answer it, or we'll even bring it up for everybody to hear. Here's the overall schedule for the Appathon. First, we really want to finalize the teams by midnight tonight. So let's say you're here and you have a friend that hasn't even heard about the Appathon, but you thought they'd be pretty interested in it. So you can send up the signed up spreadsheet, and then you can also send them the recording of this. They can watch it and be like, oh yeah, this is absolutely something I want to do. And then they can sign up as well. But again, everybody who's here, everybody who's not here and signing up later, we really want to finalize the teams by midnight. And we want to do that so that all the teams, all the groups can start working on it right away from now until February 6th. It's up to you and your group how often you and the PI and the team meet and communicate. We recommend that the absolute minimum is once a week, but ideally, and if you have the availability, you'll meet multiple times. Furthermore, there will be iOS Apple office hours on the next 2 Fridays from noon until 1 p.m. In these, you can bring some of your bigger picture development framework questions, and someone from Apple will be there to help work with you on these questions. There will also be several Appathon build days, and more on that later. And February 6th is the day before the final event. And that's when we need the group's final pitch presentations uploaded. And in some of the communications, you'll get the information exactly how you will upload it. But again, February 6th, we need those slides. And then the final event is on February 7th. It will be on campus at UC Berkeley from 4 p.m. to 6 p.m. And the teams will be presenting their prototype to a panel of judges. Speaking of the final event, we want to give you a little bit more insight about what to expect and what you'll be judged on. So with that, I'll pass it on to Julie McShane, who'll talk a little bit about the judging.
Thanks, Nate. Hi, everyone. I'm Julie McShane. I'm the Director of Career Development and Alumni Relations at the Fung Institute. And I'm so excited to be here today. This is one of my favorite events, and it's great to see how many people are excited from the UCSF community, industry, and the UC Berkeley campus. We have had over 100 students express interest in this Appathon, and so many of you are here tonight. So great to see you. Thanks for spending your time with us. Thanks for your interest in this. And it truly is a very unique event where we're pulling the two campuses together. The Fung Institute students and students across campus are coming together that have cross-disciplinary skills to really work on real-world needs in the medical community. And you can truly have a difference. In the past, some of these projects have gone on to SkyDeck, which is the accelerator on campus, or they've spun out into capstone projects within the Fung Institute. So you can show up and learn some things and leave it here, or you can continue with this work. And who knows where it will go next. So I do want to share the final judging criteria with you. It's something to think about as you're going through the design phase. You can always refer back to this. But at the final pitch event that Nate mentioned on February 7th, your team will have the opportunity to pitch your solution in front of professionals from the digital health field, including representatives from Apple, Berkeley's bioengineering department, the House Fund at Berkeley, which is a pre-seed and early stage venture capital fund for Berkeley startups. So it's a good opportunity to get some exposure to pitching and to get feedback from experts in the field. And it'd also be a really, really fun event. So the criteria that they're looking for is one, demonstrated consumer need. So does your team articulate the societal impact of your solution and the needs of the user? Innovation, how unique or novel is your team's design to address the proposal? How impactful is your specific solution to the customer group? Market readiness, how refined is the prototype deliverable? How well does your team solution address the need outlined in the proposal? Effective use of Apple Kits, how well does your team implement Apple Kits to support the development of the prototype? And overall quality of the presentation. So does your team come across, how does your team come across in terms of public speaking, the visual communication, supporting materials, and overall engagement with the audience? You'll see linked here is the resource folder that is live now. We can drop it in the chat. You can find today's presentation, and that will include the judging criteria. So next, I want to review the final pitch template. So each group will have 5 minutes to pitch their app prototype. And within that 5 minutes, we suggest breaking it down into these components. Every pitch will be a little bit different, but overall, this is the template that we suggest. Having an intro slide. We want to know who you are, so let us know your project title, the team members, what departments and majors you're from. The problem description. So you might spend a minute on this. Remember, the judges will be new to this problem or challenge, so give us context. And then the app demo. So this might take 2 to 3 minutes. It might be the real bulk of your presentation. The demo can range from anything to something in the Xcode simulator, a video of somebody using the prototype, or slides that resemble more of a storyboard. So anything is okay. Any kind of progress that you made is wonderful. All presentations, we've seen them in many different forms. But some sort of demo we do want to see. And then future iterations. This is only a 2-week sprint. So the development phase is pretty short. You'll get a lot done. It'll be really exciting. But we also want to hear maybe a minute highlighting what you would do next if you were able to continue working on it. So all slides are due on February 6th at 9 a.m. And that should give our team enough time to get everything organized for the final event. In the final presentation, we do expect it to be a joint presentation from the UCSF PI and people from the Berkeley team. And once again, it's in person, a great opportunity to get feedback on your ideas. There'll be food and mingling, and it will be a great way to wrap up this event. And finally, there are prizes. So if we didn't get you excited enough, there are also prizes. So in addition to learning new skills, if you're coming in with no coding experience, great, you'll learn. If you have coding experience, wonderful, you'll be able to really apply it. You'll meet new people, you'll work across departments, you'll network with lots of folks in industry that we have here in the judging panel. And really, like I said before, this is an opportunity to make a difference out there in the medical community. But here's some prizes that we've put together. For those, a lot of people are interested to continue these projects or at least get plugged into the innovative and entrepreneurship ecosystem, both at Berkeley and UCSF. So the winning teams will have an opportunity to meet with the Citrus director, the Citrus Foundry director, which is an incubator on campus, and then also meet and greet with people from the UCSF innovation ecosystem. Special recognition from Apple and gift card prizes for the top 3 teams are part of the prizes as well. So please continue to drop in any questions in the chat as they come in. We can get to them as we go. But I really look forward to the build phase and watching you all develop and supporting you throughout the Appathon. I am now going to turn it over to Alicia Mandak to talk about some next steps.
Thanks, Julie. Hi, everyone. For those who don't know me, my name's Alicia Mandak. I am on the UC Berkeley side at the Fung Institute on the career development team, helping to support this event. So wanted to give you some logistics in terms of next steps of what to expect. So for today, like Nate said at the beginning, it's really important that you confirm both your team members and also the team lead and point of contact. So again, we'll put the sign-up sheet in the chat. For those who are able to be the team lead, make sure that you have bolded your name. We need at least one team lead on each team. You're considered the point of contact, the person that is responsible for submitting the final slides and making sure that everybody is in communication. So be sure to finalize all that by the end of the day today. And also, if you are on the waiting list, really just make sure you're in communication with the PI and PIs. Make sure you're in communication with the people that have you see on your sign-up sheet, just so that everything can get finalized so that you can already start first thing tomorrow morning on this challenge. If needed, we do have some Apple products. We have Apple Watches and some Apple laptops to reserve. There is a sign-up sheet, which will also come to you, and I think already has come to you through an email. This we'll put it in the chat right now, is for the to reserve those products. There'll be 2 different times that you can come and pick those up on this Friday and next Monday. You'll see the times there on the screen. Friday from 11 a.m. to 1 p.m. and next Monday, 9 a.m. to 11 a.m. That's going to be in Shires Hall. If you are unable to make it during those times and did want to reserve one of those products, that would be an outreach to myself or Julie, and we can work that out with you. And then importantly for this time, you'll have breakout sessions after the presentations, and that's really going to be your time to ask some of those initial project questions of their PIs and the other folks that are on the team. So make sure to make use of this time that we have reserved for you and stay all the way through those breakout sessions. And then after today, there is, and I see in the chat here about the view only, we'll fix that for the reserve sheet. Thank you so much. So for the development phase, so you can expect some weekly communications in your inbox. So make sure that you keep an eye out for the ones that say iHackHealth, and those will keep you up to date on all the information and reminders that we want to make sure that you're in the know of. The Apple office hours, like we talked about, those be hosted on Zoom. And then you have the build days that are reserved. So we have 2 rooms in Shires Hall, Shires on the 3rd floor, 311 and 314. This coming Friday, Monday, and then the next Friday, where those rooms will be reserved for you and your teams to come and do any of the building that you want to do in person. They'll be reserved for you. And if there's any sort of issues with building access, all of the MN students, our Master of Engineering students, have access to Shires Hall, and there's at least one MN student on each of the teams. So hopefully that will help with some of those sort of logistics. And then just again, another reminder that the resource folder, you'll have access to that. There's a lot of information that we've already shared here and that you'll continue to get. And so a reminder that that resource folder is available to you as kind of your one-stop shop for all the information that we've shared with you and will continue to share with you. So make sure to bookmark that as well. And looks like we've got that reserve sign-up sheet updated in real time. So thank you very much. And then I think I'm going to turn it back over to Nate for the videos.
Great. Thanks, Lisa. I don't think there are any questions in chat that haven't been addressed. I'll pause very quickly here in case there are questions that anybody has that we can address before playing the videos. All right. Again, feel free to put any questions in chat and we'll move forward with the videos.
Hi, I'm Stephen Greenwich, and I'm the founder of Metacode. With Metacode, we're building the first wearable AI for physicians. My background is being a UCSF and UC Berkeley graduate in the Master of Translational Medicine program. I graduated recently in 2022. I've also spent my career as a software engineer at various healthcare AI and telehealth startups in the Bay Area and up in Seattle. The problem we're trying to solve with Metacode is one of physician burnout that is really huge right now in the medical industry. Physicians spend about 15 to 20 hours per week on administrative tasks. A lot of this time is spent on manual processes like writing clinical documentation after every appointment. This leads to physicians burning out. It leads to them spending less time with patients, and ultimately, it leads to negative health outcomes. So it's really a big problem across all specialties of medicine. With Metacode, we're building the first virtual scribe running on wearable AI, and we're building this for Apple Watch. What is a virtual scribe? A virtual scribe is an AI-enabled application that listens to the audio of an appointment and automatically creates the clinical documentation that takes so long to write. Now, there's a number of virtual scribes on the market today already, except they all require maybe a laptop or a smartphone, and they're really cumbersome to lug around, and they miss out on important context that we could plug into the AI. So what we're building is a watchOS application alongside an iOS application to really capture that context and have this wearable always go around with the physician. Through this project, we're also going to be building and improving upon the generative AI application we've already built at Metacode. If you're interested, please reach me at greenwich@berkeley.edu. I'm going to try to come to the kickoff session, but I may have a conflict. So if I'm not there, I'll be reaching out to all of you who have signed up individually. And also just send me an email too if you're interested. Thanks.
Every year, 1 million babies die on the day they are born. With proper care, 80% would live. Babies need time-sensitive intervention or they will not survive. With conflict and migration, children all over the world are being lost on the day they're born. But we have a glimmer of hope for the most defenseless. Breath is a smartphone application that provides real-time guidance to healthcare providers as they resuscitate newborns. With this 2024 hackathon, I'm looking for a team of motivated and excited people who would like to bring this from concept to reality. We could achieve a working example that could start being used in trainings for clinicians now. Thanks for considering this project, and I look forward to talking with some of you about this more very soon.
Approximately 200 million people worldwide suffer from neurological disease. Stroke, epilepsy, and Alzheimer's disease are the most prevalent among them. Electroencephalogram is one of the most important tests in the neurological disorder diagnosis. It is a test to see what is happening inside the brain. It was performed by putting electrodes on patients' head. However, 1 in 5 EG recordings from community hospitals are unusable due to improper sensor placement. The current placement relying on scalp measurements and anatomical landmarks. The method prone to error and inconsistency. Here comes our EEG Assistant mobile app, your all-in-one solution for flawless EEG recordings. Here's how it works. Step 1. The app will construct 3D head model from a video of head. Step 2. Align the template sensors onto the 3D constructed brain. Step 3. The app will superimpose a 3D model of the brain onto the patient's head, guiding you to each placement point with pinpoint accuracy. Finally, the app confirms correct positioning with the white dots and alerts you to any inaccuracies with a red light. The app will also integrate with our innovative multimodal platform to guide surgery planning. By leveraging the power of mobile technology, we can revolutionize this essential diagnostic tool and ensure accurate brainwave readings for every patient.
Our solution will address hearing loss, which affects 30 million Americans aged 12 years or older, creating an invisible barrier to communication and leading to social isolation, depression, and cognitive decline. Shockingly, this prevalent condition comes at a staggering cost. Unaddressed hearing loss incurs an annual global economic burden of $980 billion, covering medical expenses, educational support, loss of productivity, and societal costs. While hearing aids are a good solution for many, traditional hearing aids are often inaccessible due to high out-of-pocket costs, ranging from $1,000 to $3,500. Moreover, they bear the weight of stigma associated with aging and disability. But what if we can offer a more accessible solution? We propose AirPods as accessible hearing aids. The customer need is massive. The global hearing aids market is valued at $11.3 billion in 2022 and is projected to grow to $21.1 billion in 2023. And recently, the FDA transformed the regulatory framework, making hearing aids available over the counter, removing the prescription-only barrier, and making this product perfectly positioned to make an impact. Not just about accessibility, it's also about performance. Studies show that AirPods can match the performance of existing hearing aids, making them a viable alternative. So how can we further enhance the utilization of AirPods as hearing aids? We propose an iPhone app equipped with a pure tone audiometry feature. This app measures hearing levels and exports personalized settings to both the iPhone and AirPods. Any audio streamed through the AirPods will now adapt to these personalized settings, and for those with normal hearing, volume safeguards will be in place to prevent permanent noise-induced hearing loss. In the face of a growing need and a changing regulatory landscape, AirPods can become more than just earphones. They can become a lifeline for those with hearing loss. Together, let's make hearing accessible to all. And if you join us, we'll be working with a dynamic team of medical students, residents, and faculty that are domain experts in the space, have experience in public health and accessibility, and have a strong interest in entrepreneurship. We hope you'll join us.
Hi everyone, we are Team Phantom Mirror and our application aims to help resolve phantom limb pain in amputees. As for us, we are both medical students in our third and first year of training respectively. According to the Amputee Coalition, over 2 million people in the United States are living with limb loss, and each year, over 1 million new limb amputations occur worldwide. 95% of amputees perceive pain in their lost limb, which is a phenomenon known as phantom limb pain. The current standard of care for treating phantom limb pain involves mirror box therapy, pharmaceutical intervention, or electrical stimulation, all of which vary widely in their effectiveness, can be difficult to administer, and tend to be expensive for patients. In particular, mirror box therapy tricks your brain into thinking that the lost limb is present by reflecting and creating a mirror image of the limb you still have. This therapy has been shown to effectively treat phantom limb pain across multiple trials, but it can be cost prohibitive for certain patient populations. Given the large number of patients that are at risk of experiencing phantom limb pain, our team hopes to create a novel, accessible, and effective mode of therapy for this detrimental condition. We believe that a mobile application, which leverages augmented reality, offers a promising alternative to existing therapies
by recreating the perception and sensation of the lost limb in patients with phantom limb pain. And this is where Phantom Mirror comes in.
We've previously developed Phantom Mirror as a Snapchat lens that simply takes in half of the camera view and mirrors it to create the illusion of a second arm with only one arm present. However, mirroring the entire image can cause a lot of background distortion, as you can see here. Despite this, Phantom Mirror still has plenty of users on Snapchat across the world. Our proposed application builds upon the prior Snapchat lens by first leveraging machine learning to segment the arm in the image, then reflect the segmented arm using augmented reality in order to create the illusion of the missing arm, in order to resolve the patient's phantom limb pain. Thank you for listening, and we hope to have you join our team.
Every 2 minutes, a woman dies of cervical cancer worldwide.
Across the globe, cervical cancer claims the lives of women. A silent threat, often undetected until it's too late. The traditional screening process, reliant on expert pathologists, is limited, leaving many in resource-limited regions without access to timely detection and treatment. But what if there was a solution that could change this narrative? Introducing Saratani AI, an innovative web application powered by artificial intelligence, designed to transform cervical cancer screening. Saratani AI employs advanced deep learning technology, utilizing convolutional neural networks to automate the analysis of Pap smear images. This breakthrough eliminates the burden on pathologists, enabling efficient screening and early identification of precancerous lesions. With the collaboration of medical experts, AI researchers, and engineers, Saratani AI becomes a beacon of hope, empowering doctors in research-limited settings to perform accurate cervical cancer screening without relying solely on scarce expertise.
They developed 3 different algorithms which will be trained to obtain the best performing algorithm. We are also currently collecting Pap smear slides from 2 tertiary hospitals in the country so that we can train the algorithms by using data from our local settings. We are requesting an assistance to develop the user interface for our system that can be integrated to the algorithm.
With Saratani AI, the fight against cervical cancer becomes a shared mission, a future where every woman has the chance of a healthier tomorrow. Together, we can make history. It is within our reach.
Hi everyone, we're Team Empathize. We focus on AI LLM based application to provide personalized therapy to people with psychiatric disorders, unlike traditional services that rely solely on a psychologist's perspective. So maybe I'll start by introducing ourselves. I'm Patrick Iyengar. I'm a PhD student in materials science and nanoengineering at Rice University in Houston, Texas. I'll popcorn over to PS.
Hi, I'm PS Nandini. I'm doing my PhD in bioengineering and a joint program between UC Berkeley and UCSF. Hi, pass it on to you.
Hi, I'm Hugh. I'm studying a Master's in Science and an MBA at Harvard Business School, and spent the last 4 years as a data scientist at a medtech startup.
Thanks, guys. So as you can see, we're a pretty diverse group who came together to work on this problem. So I wanted to start by talking about the problem itself, which is mental health, using a very simple and accessible example. So meet Maya, a hypothetical person who suffers from chronic personality disorder. This constitutes rapid mood changes, explosive anger, and a lot of things along with that. And Maya, on most days, cannot muster the willpower or the energy to leave her bedroom. She just feels drained. And she doesn't feel like talking either. And she needs help, but is unable to get it. And infrequently, Maya also experiences panic attacks. And this comes with a lot of conflicting thoughts and, very self-deprecating thoughts. And Maya needs to book an appointment to go see a therapist. And this comes with a lot of trouble because you have to look at the calendar. Sometimes you have a lot of wait time till you can actually see a therapist. And if it's a Saturday or a Sunday or a holiday, you can't really get that much help. So this is a bigger problem than we imagine, because almost 1 in every 2 people, and this is a crippling statistic, is almost half the world's population is projected to develop a mental health illness at some point in their lifetime. And just a cute illustration on the right side to see what that is like when you try to compare the number of therapists to how many people there are out there who need therapy. And because of that, a lot of people go untreated, and the stress and the burden is far more in low-income Asia Pacific population. So to our solution, the Empathize app. So what we're all about is using AI LLM or generative AI-based digital therapeutics. We seek to offer personalized therapy in the form of very natural, seamless conversations with the patient. And what we really want to make with your help is a platform that would ideally be gamified, that would try to convince the users, or at least encourage them to keep returning to the app to gain long-term therapy. And we would also want this to be tunable to real-time fluctuations in patients' health. Now I'll popcorn over to Hugh again, who will go over the technical specifications for the app.
Great, thanks, Satvik. So, looking to throw together a working prototype of exactly what Satvik described, and for that, we're looking for a full stack engineer. That being said, definitely someone who's a little more focused or more experienced on back-end engineering, we think would be more helpful for what we're trying to build. It'd also be great to have someone familiar with the Microsoft ecosystem. We've won a massive amount of credits through the Microsoft Startup Founders Hub to use their ecosystem. So that's what we'll be developing in. And we're going to specifically focus on the development of a mobile app. So experience in that space is fantastic. And last of all, experience and or at least interest in working with LLMs and AI will be a massive plus for us. And generally speaking, we're working to develop a prototype, but we'd love to find someone that we get along well with and could work with in the future and bring into the team for the long run.
Thanks, Hugh. So as Hugh mentioned, we're very open to working with you guys. Thank you so much for your interest, and we hope to work with you soon.
Hi, my name is Jenny Jancy, and our team is working on AI-assisted ultrasound diagnostics. Each year, 140 million people in the United States visit the emergency department. The main reasons for this visit are injury, abdominal pain, respiratory problems, and chest pain. And ultrasound can literally help diagnose each of these emergencies quickly, safely, and accurately. However, many providers are not using ultrasound. We interviewed hundreds of people and found that 89% said one reason is because there are major workflow and documentation barriers. And 85% said that people aren't confident enough that they're using ultrasound correctly to make sound decisions. So that's where this mobile app comes in. AI can help capture the correct ultrasound images, help interpret the correct diagnoses, and automate the documentation process. This app can be used right at the bedside when assessing the patient. As the doctor performs their exam, the app will ensure that they capture the correct images and interpret the study correctly. On the right is a wireframe example of a trauma ultrasound scan. The second patient, Ellen Abrams, has been in a car accident, and the clinician needs to know if there's any internal bleeding. The provider can click on their patient when they're performing the ultrasound scans. As they are saving their images, the different ultrasound views of the study will be populated, making sure that it captured all necessary images. A red exclamation mark shows that something is wrong. AI has identified and outlined internal bleeding, otherwise known as free fluid. They can click to see the documentation pre-populated with the findings, the positive interpretation of the study. They can make any necessary edits and comments and swipe to sign. This is sent off to the patient's health record, and all of this is done right at the bedside. So we hope you'll join us in making ultrasound the stethoscope of the future. With AI-guided ultrasound, any treating clinician will be able to see inside their patient for effective diagnoses. We're so looking forward to working with all of you during this Appathon, and please feel free to bring all your creative ideas along with you. Thank you so much.
Hi, everyone. My name is Derek, and I'm the founder of NeuroTrack and an incoming neurocritical care fellow at UCSF. In our ICU, we take care of thousands of patients who've had devastating brain injury after cardiac arrest, TBI, and stroke. These patients need minute-by-minute monitoring using something called the pupillary reflex, the reflex that happens when we shine a light on a patient's eye. Changes in this reflex over time can predict neurologic worsening or progressive brain injury, and we do this in our ICU using something called a pupillometer. A pupillometer is a device that can measure a patient's pupillary size, shine a light on it, see how it constricts, and generate this readout for physicians to use. The problem with these is that they're expensive, rare, and hard to find, and as a result, tens of thousands of providers around the world are left without access to state-of-the-art neuromonitoring. This leaves doctors, EMTs, and nurses using antiquated approaches, using flashlights and their own subjective senses to try and guess whether or not a patient is getting worse. There have been several studies that have validated the use of smartphones as pupillometers using a phone's onboard camera and flashlight, but none are available on the market, and none are available for providers to use. This is where NeuroTrack comes in. We aim to build a mobile pupillometer, a smartphone application using a phone's onboard camera and flashlight, and machine learning and image segmentation technology to identify a patient's pupil, measure the pupillary size, see how it constricts in response to light, and generate a readout that doctors can use to aid in their medical decision-making. We anticipate that this device has the potential to change the way neurology and critical care medicine are practiced around the world, as well as bring advanced neuromonitoring to underserved communities and global health communities without access to pupillometry techniques. In the future, we anticipate building a suite of mobile tools for non-invasive neurologic monitoring. We hope that you'll join us on this journey, and we look forward to working with you soon. Thank you.
Hi, my name is Lynn Rosella,
And my name is Prashananda Kumar.
and we're super excited to present PD Screen, an AI-powered diagnostics tool aimed at tackling the complicated and time-consuming screening process for Parkinson's disease, also known as PD. Slowed movements, tremors, walking, balance, speech changes are all hallmarks of PD.
Lynn and I are both clinical research coordinators with the neurology department at UCSF. Every day, we work with research participants who have been diagnosed with or in the process of being diagnosed with Parkinson's disease. We hear countless stories about how long and arduous the process was for many of our study participants.
Parkinson's Foundation states that there are 90,000 people who get diagnosed each year in the U.S. alone. However, experts suggest this number is underestimated given that there are thousands of Americans who lack access to a specialist.
Wait times can be anywhere from 12 weeks to a whole year just to start the screening process with the neurologist. There are many areas with no neurologist at all. What this app can do is provide a direction for a person to seek effective care at an earlier point.
PD Screen is a video-based assessment tool that will utilize the user's smartphone camera and computer vision. After analyzing the video, PD Screen will assign a score to the user based on the MDS-UPDRS, the gold standard that specialists use to evaluate PD.
PD Screen will solve two major problems. It will reduce the time it takes for users to get screened for PD by automating one of the steps in the entire process. And two, by having the video-based record, users have greater autonomy in their healthcare. They will have the ability to provide useful information to the neurologist, allowing for more reliable detection. And additionally, we'll include screening questions for non-motor symptoms that often precede the motor change.
We've also been lucky enough to gain the support of the Vice Chair of Clinical Research for the Department of Neurology, Dr. Tanner, and Dr. Luthra. Both Dr. Tanner and Dr. Luthra are highly regarded in the PD community and have over 50 combined years of experience in this field.
So as you can see, PD Screen has the potential to make an enormous impact, and we hope you'll join us to make PD Screen a reality. Thank you so much, and we look forward to working with the talented students at UC Berkeley.
Great. All right. Well, if that didn't get you guys excited, I don't know what will. Those are really, really exciting projects. Well done to everybody. Thanks for submitting those. And for the people who are still signing up for these projects, the links to each of those individual videos will be on the sign-up sheet. All right, now it is my pleasure to introduce Tamira James, Technology Evangelist on the Developer Relations team at Apple, who will now present on different development frameworks. So thank you very much, Tamira. We're really excited. We're so glad you're here. And without further ado, the floor is yours.
All right, thank you so much for having me. I am extremely excited, even more excited now that I've seen all of these amazing pitches. And this handsome guy next to me is also Mark Malone. He's also a technology evangelist here at Apple. And yeah, so I'm gonna go ahead and share my screen really quickly. One moment. Let's get Keynote going for you. Let's see. Let's share screen first. Okay. Okay, can you all see this? Good, perfect.
Looks good.
Okay. So yes, my name is Tamira James. As mentioned, I'm a technology evangelist on the developer relations team here at Apple. And a lot of what I do includes helping developers figure out what tools and technologies we have to help them bring their ideas to life. So with that being said, without further ado, let's welcome to this awesome review we're going to do on Apple frameworks for building health-related apps. Now, the iPhone, of course, needs no introduction, right? And neither does the Apple Watch. The two of them together create this seamlessly paired experience for users. And of course, from a consumer perspective, these products are very much well known for their amazing design. But however, that beauty is not just skin deep. The iPhone is basically the most popular target for developers who are looking to build health-related solutions. So those who are looking to integrate, fitness and heart-related data, they often look into including the Apple Watch. I know several of you have mentioned the integration of Apple Watch and made me extremely happy in order to add a more in-depth and layered experience for their users. So what is beneath the surface of these beautiful designs? Well, beneath the surface, these devices are packed with technology that powers many of the features that we now expect out of our portable modern devices, right? So walking through some of these amazing sensors, we have a microphone for making calls or talking to Siri, a light sensor for setting the screen brightness based on the ambient light conditions. And of course, no iPhone is complete without the amazing set of cameras for filmmaking, photography, or even video conferencing. Also, there are radios for exchanging data and voice over a network, Bluetooth for connecting to your car or to your headphones, and even location-based sensors that help you determine where you are, the object you're facing, or the direction you're traveling in, and even how fast. But these sensors aren't just built for built-in applications to use, right? The data generated by these sensors are accessible to view and utilize directly in their raw form and rolled into high-level development frameworks that we collectively refer to as the iOS SDK. And it's the combination of the hardware and the iOS SDK that enables you as a developer to do some really, really amazing and interesting things. The iOS SDK basically groups sensors, all the data from the sensors and functionality into a series of sub-development kits that we call frameworks. So when thinking about the app that you'd like to create, it's really all about deciding which framework basically provides the easiest path to implementing that particular feature. For example, we have the Vision framework, right? Our Vision framework can take image data and process that data in a number of useful ways, like barcode scanning, for example. And when it comes to barcodes, the vision framework basically supports a variety of types, and those, especially including those popular in the medical field, like micro QR on prescription bottles, specimen tubes labeled with code 39, 128, or data matrix. And since this barcode scanning capability is built into every iPhone and iPad, you can eliminate that cost of single-purpose scanning devices or licensing fees of third-party scanning libraries. And you get the ability to scan documents on OCR as well. Now, beyond the simple barcode scanning, the Vision Framework also has a process. It can also process image data in other magical and intricate ways, such as providing feature detection on a human face. Feature detection in the Vision Framework takes the pixel information in an image and provides special details for our facial landmarks. Okay. It not only detects that these landmarks exist, but it can provide exact information on the positioning of each of them. Okay, so what are these landmarks? These are your eyes, your nose, your cheeks, your lips, even your dimples, right? And one use case for utilizing this data could be calculating the distance between each feature. Perhaps for checking if things are, some things may be off, right? So checking for abnormalities that may indicate a stroke. So for example, if the mouth is slightly turned down, or make other determinations based on historical change of relative position. And these measurements can be performed in snapshots or in real time as a person performs a series of facial exercises or tasks. So if the purpose of your app was to detect these facial details, then the Vision Framework would be the perfect framework for you. The Vision Framework is a rich tool that can detect many other human features, including poses. Hand pose detection provides you the landmarks for the phalanges, the joints, and the wrist. And this is super helpful if you need to make hand mobility measurements to compare against a normal or desired baseline, or even convert sign language to text. And even beyond hands, the Vision Framework provides pose detection for the entire body as well. So it can provide you the position of these body landmarks beyond just our eyes, our nose, and our ears, but our neck, our shoulders, our elbows, our wrists, and even the lower body, the hips, the knees, and the ankles. And like facial feature detection, it works with snapshots, movie captures, or in real time. So that was just a brief highlight of the Vision Framework. And I've only touched on a few of the interesting ways you can use it to work with the image data in your app. And another incredible framework would be Core Motion. So Core Motion combines information with the gyroscope, our accelerometer, and other sensors to allow your app to track motion without the use of the camera. I heard one of the teams mention that earlier. Motion tracking provides real-time measurements of motion in 3 dimensions. And basically, this is all based off of the motion of the device. You can collect motion information, whether your device is in your hand or in your pocket. And this will be all presented as time-stamped positional data that you can use to graph in interesting ways. You can also process this information to determine predictable movements like the number of steps given in a given steps over a given time span, or determine the distance moved, elevation change, pace, cadence. But motion measurement is not just available on the iPhone. The Apple Watch has the same sensors to determine gravity, acceleration, rotation, and all of this is super useful when your iPhone isn't around, right? Or when you're simply looking to track your upper body movements. For example, tracking hand gestures, sports activities, or progress of recovery from surgery, or pretty much any other physical debilitating events. In addition to iPhone and Apple Watch, our AirPods have motion sensors as well. I got extremely excited when I heard the team mention the use of AirPods because yes, they have so much more capability and functionality outside of just listening to media. And they provide the same motion measurements for the head, perhaps tracking tremors, posture, or flexibility after a neck injury. So if your app needs to track and process motion data, then the Core Motion Framework is a great place to start that journey. And if you're thinking about, how you may want to incorporate motion data in your app, but you're looking at this raw data and it has you scratching your head as to how you're going to map out the actual physical activities, interpreting this data in your app in real time is a task probably best for machine learning. And that's where our Core ML framework comes in. You can use Core ML to leverage machine learning models to process that motion data, allowing your app to interpret the data in arbitrary ways that you've defined, thus turning your app into an intelligent app armed with the smarts to interpret motion data in a manner that makes the most sense to your researchers, your clinicians, your data scientists. So yes, AI. So let's take this example. In this example, we have users' motion data from jumping jacks saved here as comma-separated values in a text file. Repeated runs of the action to build up a good representative set of data is a great way to get started. Now, once that data has been saved, you're able to place the data files into a folder and give it the title of the action you want the model to predict. So in this case, this is the recorded data from our jumping jacks action, okay? You would then drop the folder into what we call the Create ML developer tool, which is inside of Xcode or IDE, and it will generate a model for you to drop right into your app. And then your app can pass the motion data to the model, and the model will output a result that includes the top predicted action name, along with a confidence score. Right? Pretty cool, pretty thorough, right? Now, if you already have models built in other contexts and you have experience building machine learning models and you have some that you might want to utilize, maybe you've built some using IBM Watson or TensorFlow or Keras. We do have an open source project called Core ML Tools, which is essentially a Core ML converter. Okay, so this is a Python-based tool that can be pointed to your existing model. Okay, once your model is run through the Python Core ML tool, it'll be converted to the Core ML format. And because it's Python, it means that you can also create a cloud-based application as well. Since these models can be generated periodically based on new learnings across your apps, the models can be distributed to devices concurrently without the need to recompile or deploy your app. All right, so that was a pretty quick overview, surface level view of the Core ML framework and how to quickly combine tabular motion data with machine learning into your app. But keep in mind that beyond just tabular motion data, the Core ML framework can classify high-level data types, including audio, image, and video. For example, classifying the sound of a crying baby. You can create a classifier within your app so that it can detect this particular sound and basically have it give you feedback on that sound. So those are some great frameworks that not only would be helpful in building amazing health-related apps, but basically these are great frameworks that could be useful in games or education or just about any other category of apps, right? But now I want to run through 3 frameworks that we specifically designed for building health and fitness related apps. They are called Health Kit, Care Kit, and Research Kit. These frameworks are focused on providing high-level access to health data and pre-built user flows that are common in health and fitness related apps. So let's walk through each of these in detail. So starting with Health Kit is built into the OS on Apple Watch and iPhone. And its most basic definition, Health Kit provides the capability to allow the Apple Watch, the iPhone, and your health app to read and write health data stored in a central health database that we refer to as the Health Store database. Now, this Health Store database supports over 200 different types of health information, and they're all stored in a standardized format, okay? So a lot of the things that came up in some of your team presentations, the blood type, oxygen, blood alcohol levels, detecting strokes, caffeine levels, all sorts of things, over 200 different data types of just health information. Now, some of this data is also automatically provided by the sensors and the intelligence that are already built into the iPhone and Apple Watch. And it all gets stored right into the health database, which you'd have access to directly within your app. And we call these mobility metrics, right? Okay, so these are basically, basic mobility and capability tests and values that would typically be captured by a doctor or a physician or a clinician and so on and so forth in the medical field by doing a series of tests, okay? Because these metrics are captured and stored via the iPhone, which is typically living in someone's pocket, and the Apple Watch, which lives on the user's wrist for most hours of the day, we can collect that data and compare it over long periods of time. So essentially, by someone simply having their iPhone in their pocket or their handbag or pretty much anywhere near the center of their body, HealthKit provides metrics such as our walking speed, which is how fast a person travels over ground, and or step length, which is a person taking short, cautious steps, or are they taking long, confident strides? Double support time, which is basically the percentage of walking, the percentage of time during a walk where both feet are in contact with the ground, right? Or walking asymmetry, which is the calculation of time comparing walking speeds between the left foot as opposed to the right foot. So that is very, very specific. And all of this data is available to you. Mobility metrics from Apple Watch wearers extend simply counting the flights of stairs traversed into how fast a person is going up or down. Apple Watch uses activity clues that happen naturally over a week to estimate what a person would score on a 6-minute walk test. And finally, our VO2 max is available and accurately supports people with lower levels of fitness. So instead of requiring running level effort, our Apple Watch can produce and predict our VO2 max using slower walking speeds. And of course, if the wearer is periodically checking their ECG, the results are stored in the health store. So your app can access the results of the test for both positive and negative outcomes. Now, a mention of privacy is important here. We wouldn't be Apple otherwise, right? While HealthKit provides a mechanism for you to access any information stored in the health data store, the owner of the information needs to be aware of which data is being accessed and give their explicit permission for each sample type. By default, the health store access by any app, it's blocked until permission is granted by the owner of the data. Permission requests are presented in a consistent system-provided user interface where the data owner can toggle on or off these read or write permissions. And while this is extremely important, as some of you developers in the room can see, it's not extremely complicated to implement. So what we have here is you basically build a set of the types of data you'd like to read and write, then pass them to a function that automatically displays the request for permission. And once you have that permission, you can use the appropriate HealthKit APIs to access the samples at a granular level, or combine the statistics accurately. Here's an example of how you would retrieve data as the user takes steps. So you would simply specify the type as a step, specify the duration of the samples, and whether you want the limit, you want to limit the number of records and have it stored. Then you'd execute the query and process the results. Pretty straight to the point. If you want to have your app notified every time there is new data of a given type, you'd use an observer query to specify the type and the time at which you want to start receiving updates. Or if you're building a list that you're going to summarize anyway, you can do it in one go by simply specifying the health data that you want and how you'd like it to be collected all together. Now, these queries I mentioned work across the bulk of the sample types accessible via HealthKit. However, there is a special type called health records. Now, rather than being generated by a device or entered manually, these records are added via an encrypted mechanism. And this is built into the health app on iPhone. You basically launch the app and search for your provider. Once selected, you make a direct connection to your provider's EMR using the same credentials you use on their website. And then the health app receives the health records coded as FHIR data. And because it's in the standard FHIR format, we're able to provide more friendly display strings for labs and vital signs. And then we also have the ability to aggregate that data and all the data that has come from various sources. And then to retrieve those medical records from within your app, you use the specific, I'm tongue-tied today. You'll use the specific query for this sample type to access the data. And the data will be returned in FHIR format. Now, if the idea of parsing FHIR in your app feels a bit daunting, we've created an open source package designed to simplify its use. It's located on GitHub and it's called FHIR Models. It's in a Swift package format and it's easy, super easy to use and to add to your project, and provides validation and Swift-friendly access to JSON data in the FHIR format. Be sure to go ahead and check that out at github.com/apple/FHIR models. So that's a brief overview of HealthKit. And it's your gateway to a centralized store of health information generated by Apple and other connected devices and accessible to any app. Now let's take a look at the other two specialized frameworks designed for health. We have CareKit and ResearchKit. Both frameworks are provided freely by Apple as open source projects and housed at researchandcare.org. So on that site, you'll find a great overview of what each project provides and some examples of apps that use ResearchKit that you can download directly from the App Store. And we have some good representative apps that are using CareKit as well. And of course, the complete source for both. While distinct and unique, these frameworks are often combined in an app looking to use the features for both. Now, the most prevalent features of these combined roll into three main categories of onboarding, tasks, and active tasks. To support onboarding, these projects give you pre-created screens and flow logic that you'll use and can add to support to many of the processes often required by anyone using your app for the first time, including forms that support arbitrary questions designed to assess eligibility, prompts for consent and collecting a signature, and flows for account creation and login login that support passcode and biometric authentication. Here's an example flow where we're being asked to provide consent before we can begin using the app. With an instruction step containing body items we can easily customize, followed by the legal details of the consent agreement and an area where we can collect a signature. There's even built-in screens to pre-flight any required prompts for privacy-sensitive information. Information such as access to specific health sample types and the ability to receive notifications. And finally, access to device motion. The last page is the completion step that lets the participant know that they're all done and thanks them for participating. I'm sure you'll find this and many other onboarding flows very useful. And again, these screens are already built. They just need to be customized with the data pertinent to your particular app. Next, let's quickly take a look at tasks. Tasks are common bits of user interface and functionality often strung together as a survey. So here are some predefined objects for collecting the answer to a question in just about any format, from true to false to capturing a picture or a video. And here's an example flow of a quick check-in task. Here's displaying a couple discrete scale tasks to collect numeric values. And there you go. If your app is collecting input or survey information, just specify the series of tasks, populate them with your own text, and then collect the data. The frameworks are in charge of making sure they look great and work across any version of iPhone. And the last category, of course, we have active tasks. Active tasks are typically more complicated exercises that combine access to sensor data with a customizable user interface for going beyond just the simple data entry. So for example, the range of motion task, which guides the user through a task simply by using audio clues. Then it uses voice prompts to indicate the next step to be executed.
Place your device on your left knee. Tap the screen and extend your left knee as far as you can. Touch anywhere to continue. When you are done, return your left knee to the start position, then tap anywhere.
Okay. And now we have a completion screen when the task has been successfully performed. So it's a complete walkthrough of how to collect this motion data from someone who's just holding their phone close to their knee. And you have access to that data within your app, and you can analyze and figure out if that range of motion is something that makes sense or not. Okay. So that was probably the quickest review possible of the capabilities of both CareKit and ResearchKit. But there's so much more to explore and experiment with, including a charting package, including charting packages and extensions to synchronize data with your medical backend. So go ahead and be sure to check out the website, researchandcare.org, for a complete list of what's included. Now we've got that brief overview of CareKit and ResearchKit. That is a wrap of the overview on our health and fitness specific frameworks. So these combined frameworks, combined with the power of the other frameworks built on the iOS SDK, ensure that you have all the tools that you need to build the next great health app. If you have any questions regarding any of the tools that we discussed today, or are still not quite sure where to start, feel free to shoot me an email, and we can arrange a chat later on. But otherwise, we're going to have open office hours as announced earlier, and we will definitely be able to go into further detail. But with that, I'm wrapping up my talk. Thank you so much for listening. And yeah, I'm passing the mic. Thank you.
Hey, Tamara, that was awesome. Thank you very much. Really, really sharp. One of the things that I've noticed over the past few years that I'm sure everybody else has been the development of AI and ML over probably even significantly more in the past year. And we noticed that in a lot of the projects that applied to the Appathon. So I'm really glad you highlighted the core ML framework. Great. All right. Thanks again, Tamara. We'll see you in the office hours. All right. So now some tips for a successful Appathon. The first thing that I always like to say is to remember you want to employ design thinking. Keep on thinking, who is the user? How will they be using the app? When, in what circumstances, et cetera, et cetera, et cetera. Also, you'll want to iterate often, especially with your PI, and really work as a team as you iterate. Also, sometimes 10 people and even more with the wait list can be a really large group, and that's why it's really important to develop a work plan. Delegating different tasks and subtasks of the project can be really helpful. And developing a work plan is very important, even if you deviate from it later on. And this is why meeting with your PIs is going to be so helpful, especially if you start early and meet as often as you can using the different collaboration tools of your team's preference. This is certainly not an individual exercise, but a team one. So please leverage the different expertise available in the group. There's a lot of programming experience, which is absolutely remarkable, really. And I'm sure there are going to be very many other skill sets that will be beneficial to these projects. And finally, have fun. We've heard great feedback from both students and PIs over the years, and we really hope that you enjoy this experience. All right, now for the, I see, check chat very quickly. What's fun? That's funny. All right, so please join the group that you're interested in and you signed up for. Remember, as we said a couple times, you can only work on one project. In addition to you joining the team, the breakout room, the PI will also join, and you're really encouraged to use this time to meet one another. Unfortunately, we know that there's a couple groups that the PI will not be able to be there. So one of us from the Appathon team will be hopping into those groups to give you a little bit more information, continuing to communicate next steps and how you can contact the group leads. And again, we're going to wrap this up. Thank you again, Tamira, for the presentation. Thank you to the Appathon team. Julie and Alicia, thank you very, very much. All of us will be around this Zoom call if you have any questions. And, I'm not seeing any questions in chat, so I am going to stop share and I will open the breakout rooms. All right, the breakout room should be open now and folks will be able to join.
Happy building, everyone. The Appathon team will be here if you have any questions. We can pop into all the rooms too. I think Tamira and Mark are going to work their way around as well. Have fun.
Rooms are, room 1 for project 1, room 2 for project 2, et cetera, et cetera.